Click for IB Biology. Here we're looking at another aspect of ecology, which is productivity. We'll look at two features of this, the primary productivity and secondary production. There's a blank PDF of this presentation down in the description that you can annotate with your own notes. And then you can take the 10-question quiz, which is also there, and the answers are there to be checked out. So let's take a look at the idea of productivity. So within the photoautotrophs, we have the concept of primary production and net primary production. Of course, we have the incidence of solar radiation captured by our photoautotrophs, our plants here like this, and the energy which is captured and stored by the process of photosynthesis, converting light energy into chemical energy, is known as gross primary production. The gross primary production in the plant itself will only have available the energy minus that used in the process of respiration. If we subtract the energy used in respiration from the gross primary product, this leaves us with the concept of net primary productivity. The significance of the net primary productivity for the ecosystem is that this is what is available at the next trophic level for consumers. Here we're going to now move on and make some predictions in the global trends in net primary productivity relative to latitude and the types of biome encountered in those environments. Presenting here is a data set that I will also include into the description so that you can load this into any piece of software that can analyze graphs. This can actually be pasted directly into something like ChatGPT, and you can ask it to analyze the data for you. I have chosen to analyze the biome against the net primary productivity using these two different methods of assessment. For the purpose of making this a simpler discussion, I have removed the data for croplands and wetlands, but it is interesting to incorporate those afterward. Copying and pasting that into ChatGPT, this pattern emerges in our data. Notice the discrepancies between the two different estimates of productivity, net primary productivity, at the different biomes around the world. So beginning with our tropical biomes here and ending with the polar biomes on the right hand side. And so we can see that whilst there is a discrepancy between the two different methods of determining net primary productivity, the global trends are a decrease from the equator regions, from the equatorial regions to the polar regions. And we can think of that as being the base of a pyramid of energy, and the amount of energy which is then available to the trophic levels above it. We can see that there's a decline from the tropical forests all the way through to the tundra as we gradually progress to the northern latitudes. It's not simply going to the more northerly latitudes that has an influence. Of course, this is also dependent upon your position within a continental block and the availability of water. You might want to take a few moments to look at the trends in the graph, pausing your video now to spend some time analyzing the graph. There are also many other, if we take the data from the table that I showed you above, there are a number of other types of graph that you can analyze looking for trends and patterns. I've summarized here the trends and patterns from the analysis of my data here. Significantly, of course, is the things like high carbon density in forest biomes, the significant contribution of the tropical regions, and that this was largely associated with their the high intensity of light in these particular regions. The low carbon density, of course, of cold regions and deserts, the tundra regions, low primary productivity in those areas. The variation in net primary productivity between different methods. The method used to calculate has an influence over the outcome of your data analysis. Large areas of land do not necessarily equate to high regions of net primary productivity. As I mentioned, I had removed the croplands and the wetlands from my analysis so that the trends would be simpler and clearer, but it's interesting to then superimpose the cropland and wetland values and to see that they make a significant contribution to primary productivity on a global scale. Secondary production, which is concerned with the higher trophic levels above the producer, is known as secondary production and as an aspect of the heterotrophic style. Food is ingested. If we think of this in terms of an energy budget, we would call that I. And in the same way as we did with the primary producer, we're going to lose some of that energy in the form of respiration. Ingested food, which is assimilated into the organism, then will contribute to growth, but we must recall that there will also be undigested and therefore egested component. We can estimate these values with these types of equations here. That assimilation will be equal to the that used for growth, but not including that for egestion. As we move up through the different latitudes and continental position, we're aware that the base of the pyramid of energy will actually be narrow. So at the equatorial regions, it would be wide like this, and in the polar tundra region, it would be smaller. And as a consequence of this, and as a consequence of losses due to respiration, the complexity of food chains and food webs in the tropical regions are significantly greater than those available in the boreal or tundra regions. That concludes the videos for this particular topic on ecology. Playlists and links to the channel will lead you to other ecology topics.